Okay, let's see an example on how to determine the total distance traveled by a particle within a given period of time. So in this example, a particle moves along a straight line from a fixed point O. Its displacement as meter t seconds after passing through O is given by s equals to t square minus 8t. Find the total distance in meter traveled by the particle in the first 9 seconds. So before we continue on the solution, let's find out the keywords in this problem. First of all, we have the displacement function, which is given by s equals to t square minus 8t, and secondly, we need to find the total distance in the first 9 seconds. So we can solve this problem using number line or displacement time graph. But in order to draw a number line or a displacement time graph, first of all, we must come up with a table. So I'm going to tabulate the displacement for the particle for the first 9 seconds. S is equals to t square minus 8t. Let's build a table. So I'm going to tabulate the values of s and t. So the first value of t is 0, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's calculate the displacement of the particle for the first 9 seconds. How to find these values? We can use a calculator. I'm going to use a 570EX scientific calculator in order to complete this table. So first thing, I'm going to key in the s function. So in this case, I'm going to replace the t with x. X square minus 8. Again, I'm going to replace the t with x. So x square minus 8x. Press calc. The value of t is 0. Enter. We get 0. Enter again. Key in 1. Enter. We get negative 7. Enter again. Key in 2. Negative 12. And you can just complete this in order to get the rest of the values. So alternatively, we can use the table function in the calculator. Menu, look for table. So press number 9, key in the function x square minus 8x. Enter. So this part here you just skip. Start with 0. The first value of t is 0, so we start with 0 and end with 9. Okay, and step. Okay, the time increased by 1 second, so the step is 1. So when you press equals to sign, okay, we already get a nice table in our calculator. So what we need to do is just copy down these values. So with the help of this calculator, our work is going to be very, very easy. Okay, so let me copy down the values from the calculator. So let's use the first approach, which is using number line. Let's draw a horizontal line with arrows labeled with s meter. And then if you look at the table, we have both positive and negative values. The biggest value in this table is 9, and the smallest value in this table is negative 16. Okay, so we have more values on the left hand side. So therefore, I'm going to put the origin, okay, further towards right. So right here, so this is the origin, and then the particle is actually initially moving towards, okay, left, and then it made a U-turn, and after that it moving towards right. T0, okay, when T0 we have as 0, T1 as negative 7, T1, so this is negative 7, so I'm going to label this as negative 7, and then we have a negative 12, okay, and then we have negative 15, and then we have negative 16. The negative 16 is located here, okay, because the particle is actually making a U-turn at x equals to negative 16. And once again we have a negative 15, negative 12, negative 7, 0. The particle returns to the origin. After that it moves further towards right here. Okay, so we can say this is 9. Okay, and let me label the time: T2, T3, T4, T5, T6, T7, T8, and T9. And let me draw a curve to show the movement of the particle. The particle is moving towards left until s equals to negative 16, and after that it moved towards right, and at the 9th second it reached 9 meters from the origin on the right hand side of the origin. So how to find the total distance traveled by the particle in the first 9 seconds based on this number line? So we can take the distance that traveled by the particle, okay, from here to here. Okay. In this case, the particle is moving towards left, okay, and the distance is actually 16 meters. 16 meters. And later, the particle is moving towards right from negative 16 to 9 meter. So the total distance traveled, the distance traveled towards left, which is 16 meters, plus with the distance which is traveled towards right, which can be determined by taking 9 minus negative 16. Okay, so 16 plus 25, okay, is equals to 41 meters. Let's see another way of doing this calculation. So we can divide this into 3 sections, from here to here, which is 16 meters, and then from here to the origin, which is another 16 meters, and then from the origin towards the right, which is 9 meters. 16 plus 16 plus 9. So the answer is the same, which is 41 meters. So let's see how to answer this question using displacement time graph. So first of all, let's use the information from the table and then sketch a displacement time graph. Displacement time graph. So we label the horizontal axis with t seconds, and the vertical axis we label with as meters, and this is the origin 0. So after we completed the axes, now let's plot the points. So let's plot the graph. Let's see how to find the total distance traveled for the first 9 seconds based on the displacement time graph. So the distance that traveled by the particle for the first 4 seconds is actually 16 meters, and the movement is actually towards left. For the next 4 seconds, the particles moves another 16 meters, but in this case it's moving towards right. And later, from the 8th second to the 9th second, it moved another 9 meters. So therefore, the total distance travel for the first 9 seconds is equals to 16 plus 16 plus 9, which is equals to 41 meters. In fact, we also can solve some problems by just using the information from the table itself. For example, let's say if we want to find the distance that traveled by the particle on the 8th second. Okay. So from the values on the table, we already know that the particle is actually making a U-turn, okay, on the 4th second. So one of the crucial point that you must consider when you finding the total distance is, okay, finding the time when the particle is changing its direction, or in other words, when it is making a U-turn. Okay, so once we already identify when it's making the U-turn, okay, now we can, okay, find the distance without any mistakes. Okay, so back to the question, what is the distance that travel by the particle on the 8th second? Okay, so the answer is we take the displacement of the particle on the 8th second, and then we minus the displacement of the particle on the 7th second, and we put a modulus. The reason why we are putting the modulus is in case you get a negative value, the final answer still a positive value, because distance is a scalar quantity. In this case, modulus 0 minus -7, we get modulus 7, and the final answer is 7 meter. So if you go back to the graph here, on the 8th second, the movement is represented by this section. Okay. So the distance that travel in this section is actually the difference in the vertical distance between these 2 points, which is 7 meters. So it is confirmed that the distance traveled by the particle on the 8th second is 7 meters.